All. A very good morning, good afternoon, or good evening, who is joining from other time zones. Okay, warm welcome to everyone. Let's start today's agenda. I'll quickly refresh what we discussed yesterday and we can go from there. Let me share my screen real quick. Yep, I hope everyone can see my screen. Perfect. Yeah. So, uh, yesterday we discussed how we have evolved from, rule-based systems or rule-based AI systems to current day AI agents or LLMs and current day AI agents and everything, right? So I hope everyone understood what each step or each improvement or each new field brought in, what is the revolution, how it was able to solve the limitations of the previous version, and it also was able to generate something else. Like, for example, from the rule based to the traditional machine learning, we switched it uh, just instead of writing the plain, simple, or complicated rules, we built models that identified the patterns automatically based on the data that we have provided. And eventually, when we have seen the limitation with images or audio files and so on, then we moved on to deep learning. So in deep learning, again, we built neural networks, and then eventually, instead of handling the data sequentially, where we want to scale it and also remember things on the larger context, we introduced transformers. So with the invent of transformers, then we got into LLMs, and with LLMs also, as we know, there are certain limitations. So what are those limitations, and why did we move, or why did we build on top of LLMs? Like we built RAG applications, fine tuning the LLM, and other thing is how did we build AI agents and all these things, right? So just slightly going back, let's focus on some of the limitations of the LLMs here. Okay, then we will introduce why RAG was introduced and why fine tuning was introduced. So, till yesterday, we were clear what was the traditional, sorry, why the traditional models were not able to solve few things, where it was facing some difficulties, and why we invented transformers and LLMs. So, let's quickly revise a couple of things and then we'll jump onto the RAG on top of LLMs. So, here, if you see, the challenges with traditional AI are mostly the answers are based on the training data. That means, like in the earlier days, maybe, an year back or 2 years back, or let's say if you download a open source model onto your PC right now, uh, and if you don't have any external access, okay, let's say you don't have any internet, but you just downloaded LLM model onto your PC and you are started asking questions. So what happens over there? That particular LLM will answer based on its training data, right? So, as we discussed yesterday, every LLM model is trained on humongous data that is downloaded from the internet. We will scrape through, pass through, and we will rigorously train it on uh, those data that we have at hand, right? So, there is a cutoff date for this, right? So, like, let's say if I'm starting training today, it will be completed another 1 month or something, and the model will be released in the next month. So if you see all these models, like whether it is ChatGPT 5.6 or Claude, Opus, Sonnet, or anything, these all will models will have a cutoff date. That means their training is only up, it has knowledge only up to that training date. So if you ask it any real-time information or any specific domain information, like your company information or your proprietary information or your personal information or something that happened in the very past, like yesterday something happened with some war, global war or something, okay? Some prime minister got elected, some president got elected, assume. So it may not have enough information on the recent data. Why? Because it was not trained on the data and it has no idea what happened, right? So as you see, there was a limitation. So you can't fetch near real time or real time answers, right? So there is a difference between near real time and real time. So near real time is means like not the current data, but maybe yesterday's or day before yesterday's or that kind of data. Okay. And as we know, we can't access any latest or private data. Like if you have any private domain specific or proprietary data, like let's say you're working in a company and usually that, but the data that is available in your company is specifically not available over the public domain, right? It is most likely proprietary data, and you will have information, or your company itself will have the information in their own service, right? So the LLM has no idea what your company does, and it may not be help you in your work. And the other thing is, if it doesn't know an answer, LLMs always tends to generate hallucinated or incorrect answers. So LLMs basically have a bias as well apart from this. So what it does is, like let's say if you ask a question to LLM and it gives an answer, and if you repeatedly ask it a couple of times or multiple times stating that, oh, is your answer correct? Assume the LLM provides the right answer. But still, if you ask, oh, is your answer correct? I don't think so. And then it will say, no, my answer is correct for the first time. If you repeat the same question for the second time, yes. But for the third time or eventually fourth time, it will say, oh, no, I may be wrong. You are right. So it might still provide some incorrect responses and also give you some hallucinated answers. What is meant by hallucinated answers? It confidently gives you an answer which is not correct or which is not in the context at all. Okay. So that is nothing but hallucinated answers. Like, for example, if I'm asking any specific question, like, okay, what is my current salary or what is my team's budget? The model has no idea. It has not been trained on any of this data, right? So obviously, it will give me an hallucinated answer. It will say, oh, your current, I'm other. It will say, I don't know if we have strict guidelines, or else it will say, it will just hallucinate some random salary and random budget. It will say, oh, based on your current experience, you should be earning from somewhere like 250K or 300K. And then it will be saying like your team's budget is something like 5 million or 10 million based on what you have texted or chatted on memory and things like that. Okay. So it will just simply hallucinate things. It doesn't know the exact value, but it might hallucinate and give you an answer. So these are some of the common limitations. So with these challenges of an LLM, how to how do we build applications and minimize all these challenges and limitations? So that is when few of the other components has been attached. So in order to minimize this, they brought in RAG. RAG is nothing but retrieval augmented generation. Okay. So if you see here, here it is of two parts. Okay. One is retrieval and the other thing is generation. Augmented means we are just coupling these two. Augment is nothing but joining. Okay. So here retrieval is part one and generation is part two. So what happens in the retrieval and what happens in the generation? Okay. So retrieval is something, if you, the name itself suggests that we are fetching something from somewhere or right, retrieving something. Like how you retrieve, your data that you deleted accidentally and all those things. So you are just trying to retrieve some information and coupling it. Augment means coupling it with the query and then sending it for generator. So generation means you need to generate an answer, right? So in generation part, in this component, you will have an LLM where you will retrieve some data, couple it with the user query, and give it to the LLM. So the LLM will generate an answer based on whatever data you have provided as a context. Remember this word as a context. Context is nothing but what is whatever data or input you are providing to the LLM, that is known as a context. Context can have anything. Okay, just to simplify this, these are some of the few keywords before we go further. Okay, so what is context? Let's say you might all have been providing some, there will be a prompt like user prompt. So if you are using ChatGPT, ideally what you will be doing is your basic task is to provide just user prompt. ChatGPT will always have a backend system, will have a system prompt in the backend. Okay. In ChatGPT, if you have any new projects that you wish to create, if you go to projects and select on add a new project and it will ask you for a prompt. So there you will be either giving some instructions on how you want the model to behave and all those things, right? So what happens is system prompts is like a generic one where it will give some guidelines to the model, and user prompt is something which you want where you want how the model to behave or how you want the model to answer. For example, uh, I can say something like system prompt, I can say always give answer in the textual format and simple language, and adapt to the tune of a writer, or a poet, like adapt to a poetic style or something. Okay. So then in the user prompt, what I can give is, okay, now uh, give me a poem in the Shakespeare style or some other style, or I can instruct it whatever I can. I can say act as a judge where you can evaluate the styles of multiple people or things like that. Anything you can do. So now you'll have another agent.md basically. So agent.md, okay, let's not dive into this for now, just for simplicity. Okay, and you will have skills.md file, and you will also have tool calling information. Okay, which tool to call and all that information in general. And you'll have some memory of the sessions, or it can be long-term memory or short-term memory depending on it. Okay. And like basically these are like few of the primary components that you want to do. So when I say tool calling, it can be from either RAG also, like I'll just say information retrieved from RAG as well. It's from the vector database or anything. Okay. So now if you see here, what this whole information that you pull through, you are sending it to the LLM. So the input, this is the whole input for your model. So this is called as a context. So there is a term called context engineering. Okay. So industry has coined a term which is called as context engineering. So what is context engineering? You might be thinking, or you might be heard about, prompt engineering and all, right. So prompt engineering is something where you are just modifying the user prompt. Okay, you are efficiently writing the user prompt such that the model will do proper reasoning and will give an efficient answer. Okay, in prompt engineering, you have like few shot prompting, single shot prompting, and all those things. We'll go over that eventually. But for now, just simply understand that when you say prompt engineering, you only update the user prompt. Okay, or max system prompt. But when it comes to most of the system prompts are freezing if you are using open models. Okay, so you will be only working on the user prompt. So when it comes to context engineering, right? What it happens is you not only deal with prompt engineering, you will also deal with what you are pulling in, like what you are pulling in skills.md file, what you are pulling through tool calling function, how you are utilizing MCP servers, how do you ensure you are always calling the right tools and fetching the right information, and also ensure you are pulling the right memory also. Why we need to write memory? Like let's say you have multiple users in your database. Okay. Whenever you are pulling memory, that memory should be fresh. You should give a weightage to latest memory, and more weightage to recent memory, and less weightage to the older memory. Or you should remove your older memory from your, older chat from your memory. So how you handle that, all those things will go on eventually. But for simplicity, assume we need to handle all these aspects and we need to couple them together. So if we can couple them together or engineer them together, that is nothing but called as context engineering. Okay. And there is always a thing where LLMs also have a tendency to forget about middle layer. Like let's say if you this is your whole big context, and it has 1,000 lines. LLM has a tendency that giving more weightage to end of the context as well as to the start of the context, but it might give less weightage or forget things in between. Okay, so that happens. So why that bias happens and all those things. If we need to know all those things, we have to like deep dive into the back in how the probabilities are calculated and all those things. Okay, so we'll jump into those in the detailed sessions, but for simplicity and to cover most of the topics in the available 20 hours of the time, so let's get back to what we are discussing now. I hope everyone understood what is context engineering. So now, yes, so when I say context, okay, so I need to give the right, I need to fetch proper information, or one thing is here I want to minimize these challenges, right? So I want to fetch the latest data. So when in my retrieval, I should be able to fetch latest data from a knowledge base. Other thing is I should be able to access private data. Yes, if I am fetching from my company knowledge base, I can access all my private data and I can fetch that, right? And then can I need to limit the generation of incorrect or hallucinated answers? Yes, with the invent of retrieval, and as I'm coupling it with the user prompt or user question and passing it to the generator, right? So what I'll strictly say is give me and generate an answer based on the context that I'm providing and do not hallucinate. So it will have some guidelines where we are asking the model to generate an answer specifically based on the context we have provided and do not think out of the context. If I'm asking about something, if I'm giving a doctor information and asking about it, just give me the doctor information. Don't give me anything about nurse. Don't give me anything about a hospital, or don't hallucinate anything. Just give me the doctor information in the natural language format, right? So I hope everyone understood uh, this part, like why we introduced drag and things like that. So now let's dive deeper and understand what exactly happens in drag. Okay, so in drag, the primary thing starts at data preparation. Okay, so let's say I have humongous data in my company. Okay, so I might be having a lot of PDFs, videos, or n number of things, right? So initially, I will collect all those web pages, blogs, any README files, and everything, and I collected all this and storing it my location, GCS location or whatever cloud you are using. Just you are storing it in a storage location. And then what you need to do then you need to parse it, right? So how do you parse it? So if it is a you know HTML data, you need you can't chunk them abruptly, right? So what you need to do is you have to effectively pull all the HTML data from the web pages or anything. Like you will effectively pull all the raw data sources first, and then you will come to contextual annotation. So how do you annotate that contextually? So if you have to give any metadata to it, like let's say for example, I'm working in a company and it has all the HR related documents. Okay, you might have all seen Workday, right? So specifically Workday, or for example, customer support chatbot or something. Okay. So in the customer support chatbot, they have like various divisions, right? Like refund division, retail division, maybe membership division, maybe returns division, and all these things, right? So in general, what happens over there is you will annotate each document. So you will also annotate something like, which year the document belongs to, whether it is the latest or older. You will add versioning to it, and you will add a title to the documents and all those things. So once you annotate everything, then you will do the chunking. So how do you do the chunking? So chunking is nothing but you are splitting your document into multiple parts. Okay. So why do we need to do chunking? So probably most of you might have an idea of why we do chunking, but let me just rephrase it real quick, okay? Let's say, for example, yesterday we spoke about LLMs have a context window, right? LLMs has a context window. Maybe earlier, most of the LLMs right now has 200K, okay? And few of them has 1 million also. Let's assume, let's go with the 200K tokens. So 200K tokens means in general, each page will have somewhere like, uh, let's say roughly maybe 400 tokens, just for simplicity, okay? And I have a book which consists of 5,000 pages, okay? And where like simply assume I have a document which consists of 100K tokens, okay? So here in my raw data sources, I have documents where, each document will be 100K or 50K or so on, okay? So if I don't do chunking, And if I store them in vector database, and if a user query asks something, okay, I will fetch that chunk, which is consisting of 100K tokens, and I will provide it to the LLM. So if you see here, LLM tokens, right? Like if you see the 200K tokens, this is the limit of the input size, or it can process. So if I'm providing it 100K tokens, what happens? If I give one chunk, it is 100K. What if I give three chunks? What if I do what if I retrieve three similar chunks and provide it to the LLM? It will exceed my LLM context window. So that is limitation number one. And the other limitation is, LLMs are charged, right, based on tokens. Like maybe all the latest models are charged like $5 per million input tokens, right? So what happens here is, if I'm giving 100K tokens, like assume I only retrieved one chunk and provided 100K tokens. So if I do just 10 queries, if a simple user asks 10 queries, I might need to spend $5, which is equal to like $450 in India, or close to $500 in India, right? Sorry, 500 rupees in India. So if we keep on, I mean, if we use these larger documents, if we store them in the vector database and try to retrieve or provide the LLM larger documents, what happens over here is your charge will explode or blow up. Okay. So it is not a viable product for you to deploy it. Why? Because when you have million customers, if each of the customer is spending up $5 every minute or for every session, you need to spend millions of dollars in a day, right? So that is not at all viable. So how do you minimize this? That means, why don't we send only the necessary information that is required for the LLM to answer? So that is when chunking was introduced. Okay. What does this chunking does is, if we have like for example, let's come back here. I have a HR document which is having 5,000 pages. Okay. And I have some statements in there which will explain that my question was something about to ask about the leave balance. Okay. So in the HR document, we have a certain page or chapter where it talks about all the PTO information, leave balance information, sick leaves, and all those things. Okay. And it says, if you are a blue collar or white collar job, you'll get 5 leaves after 5 years. And if you are a blue collar job, you'll get two additional leaves after 5 years. And a temporary staff, one leave bonus after 5 years of work experience with the company or tenure with the company. So these are like on top of what we have. Like basically, they will provide like 20 PTOs plus 5 and 20 PTOs plus 2 for blue collar job, and temporary staff 20 PTOs plus 1 leave bonus something. Assume here. So in my whole HR document of 5,000 pages, I might have only 10 pages related to my leave policy, where I am explaining in detail, right? So in, if a user is asking a question, something like, okay, what will be my absence balance if I work for 20 years in this company? So do I need to send all these 5,000 pages to the LLM and ask it, like whenever I have this question, should I just send all these 5,000 pages to the LLM and wait to get a response from it so that it can, read through all the 5,000 pages and figure out where the chapter that is talking about leaves or PTOs and answer the question based on my profile, whether I belong to blue collar job or white collar job? So what happens here? The first thing is my tokens will be burned and it will be cost a lot for me. That is one thing. And the other thing is, what might happen is, if you send 5,000 pages to the LLM might confuse. Why? Because you are providing abundant information. Think of it like to a kid, okay? So think like, you know a certain person, like assume you hired a new HR, okay, in your company. So the HR's job is to, go through all these things and answer your question. So you went to the new HR who recently joined your company and you asked the same question, like what will be my leave balance if I work for 20 years in this company? Assume if the HR has to read through whole documentation, Like she will read through whole 5,000 pages. And after reading 5,000 pages on the next day, if you ask something to her about your PTO, would she able to answer, or will she might have confused or forgot things. So the probability is more like she might tend to confuse or forget things, right? Why? Because she doesn't remember all the 5,000 pages inch to inch. So what she will do is she will go to the chapter that you say where it says about leave policies, and she will only read the chapter and provide an answer for you, such that she can remember the things, right? Initially, like she can just quickly go to the chapter, see what is the company policies on leaves, and she can like quickly give an answer to you. So why don't we make the LLM also to answer in a similar perspective? Why to look through all the junk chapters? Why don't we provide the specific chapter that talks about this question, or that might have answer related to this query? So that is where we introduce chunking. Okay. And this is the background of why we need to do chunking and effective chunking also. So I will talk more about chunking, why, how effective it should be, and all in the detail sessions. So I hope everyone got an understanding why do we need chunking and why it is important. And the other most important thing is you might be asking something like, okay, you have provided text, and you're asking me to chunk it based on chapter, or how do we chunk it? So chunking can be of many types, okay? So for example, if I have this 5,000 pages, I can chunk it using chapter wise. I can chunk it using page wise. I can chunk it using paragraph wise, or I can chunk it using subheading wise, or I can chunk it using sentence wise, or line wise. You know the sentence, right? Where you give a full stop, that is the whole sentence. So if a sentence consists of two lines, yes, you can do chunking for each sentence, or you can chunk it as a line based also. Like if you have 5 lines like this, you can chunk each line and store it as a different chunk. And the other thing is you can also store as based on the character count. So like let's say if I have this whole thing, I can simply say first 100 characters comes into chunk one, and second 100 characters comes into chunk two. Okay, there are n number of chunking strategies. Okay, I will go through this in detail if needed. Um, so I hope most of you already know these topics, but if you don't, yes, I'll go through these in detail. You don't need to worry about. Let's discuss in detail at the end of the session. So then you might be asking something like, okay, how do we handle HTML pages then? So you can't abruptly split them, right? You need to maintain the structure of the HTML page, right? What is the heading, what is the body, and all those things. Yes, we do have some parsers for HTML, we do have some parsers for JSON. So similarly, we have like a lot of parsers. We can do customized chunking also. So there are a number of ways how we can effectively chunk the document and store it. So once we effectively chunk it, as we have the contextual annotation, so we will provide all this annotation to the those chunks, like which title it belongs to, what was the versioning of the document. Okay, if I have a HR document, the latest we might have like 2025, 2026, or 2024 one. So we will add all this versioning to it, and in the practical session that I'll be showing in our next session, it will make things more clear. Okay, why we need to add metadata to those, how those helps in filtering, how those helps in narrowing down our search. I will go through all these things. Okay, then once we do the chunking, our next step is embedding. As you know, the models only understand numbers, right? So if we have a sentence, how do we convert it into numbers such that the machine understands? So it not only needs to understand the numbers, but it also needs to store the semantics or the meaning of it, right? Like whatever you are saying in that sentence, it should, we should convert this particular sentence into vectors or numbers which can store the meaning. So how do we do that? So vectors is our first priority, or first way of, like best way of doing it. So in vector search, what happens is, or in the vector, what basically we do is we convert all our chunks into vector format using an embedding model. So embedding is something where you convert your text into vector and preserve the meaning of the text in the vector. So vectors are one of the most used way to preserve the meaning of the text. Okay. So once you convert all of this text into vectors, you will store it in a vector database. Okay. So vector database, you have like ChromaDB, Pinecone, like PG Vector, and all these things. And all the cloud providers also has its own vector database service. Okay, you can use any of it. If you are doing it locally, you can use Fires and all those things as well. Okay. So now you might ask me that is vector database similar to SQL database or structure other traditional databases? No. So I will explain this in detail, but assume for now these two are different. And vector database is something where it can handle matrix multiplications. Okay, the search is very fast. Okay, if you are able to do dot product on your query vector as well as the vectors that are available in the vector database, then like I mean that component differentiate the traditional database and the vector database. So I will rephrase this once again. So vector databases allows us to make matrix multiplications. Okay, matrix multiplications is nothing but dot product of two vectors, A dot B, and all those things. Okay. But when it comes to traditional databases, the search works differently. It is based on keyword search or the query language that you use over there, right? So basically, you will just go and look for those rows and you will retrieve it. So it is slightly different. So in the traditional databases, we don't have any vector um, matrix multiplications or dot products of vectors. We can't do any of those on the traditional databases. It is just purely on the query language that we use and just a plain search, keyword search, you can say. But when it comes to vector databases, no, it is basically you are doing matrix multiplication or dot product. So if a database provides that capability to you, then only we'll call it as a vector database. Okay. So now come back here. So we have a user query. Okay. If I want to ask something about my leave policy, to my RAG application or assistant. So initially, I'll be using this. Remember this thing. We had to use the same embedding model in both the steps, in indexing process as well as in the query process. Okay. So once I built my vector databases, all my indexing process is done. I have my knowledge base, filtered it out, chunked it, converted into vectors, and stored in my vector database. So now let's come to the query process. Now let me ask something to the application. So here, when I have a user query, what I'll be doing here is I'll be asking something like a question on leave policies. Okay. So I'll be using the same embedding model such that my vector dimension is same. Like if I am converting the text into a vector, I will give a certain dimension. Okay. So something called as 1536, or it will be in the multiples of 128, to be honest. Okay, 256 or 128. So we will do it like in the either 1536 or 768, or maybe double the 1536 or 2048. It will be in the multiples of 256 or so on. Okay, or 512, anything. So what you will be basically doing is you will store it in a certain dimension vector. Okay. So now, if you ask me, okay, how to decide that vector dimension and all that, we will go through in detail. Okay. So for now, just assume we have taken a dimension and we have taken an embedding model. So you will use the same embedding model in the index process, and in the query process also, we'll use the same embedding model. Okay. Then you have a user query in the textual format. Then you convert it into a vector, and then you will go to vector database and quickly do a similarity search. So what is meant by similarity search? It is nothing but cos of A dot B by magnitude of A dot B. Okay. So it is a cosine function. So it will do that matrix multiplication. Like let's say your query is A and all the other vectors in the vector database will be B. So first it will initially do all the calculations, matrix multiplication calculations with each of the vector that is available in the vector database in a fraction of seconds, and it will give you the respective scores of the dot product. So once it give you the respective scores, whatever are in top, like if in your vector database, let's assume you have 1,000 vectors. So let's say you have 1,000 chunks, and you have converted them and stored in vectors as 1,000 vectors. So you might be getting a score, and whichever vector scores highest, you are retrieving it. Okay. So this vector will be also associated with the textual information of that chunk. So you will fetch that textual information and you will provide it as a context to the LLM along with the user query. Okay, so you will couple the user query and the relevant data that you have retrieved from the vector database and pass it on to the LLM. So let me repeat this once again. So you have the user query and the information that you fetched from the chunk that you have fetched from the vector database, you will couple them together and send it to the LLM as a context. So the LLM will then look into your question and the context that you have provided and will be able to generate a response for you. Okay. So which is, if you have latest data in your vector database, then yes, it will fetch the latest and relevant data. And the other thing is, it will provide an answer based on the data that you have provided. That means you have a grounded data, right? You have ground truth, and your answer is pretty much grounded on based on what you have provided. So the scope for hallucination is very, very, very minimal, right? It will still have a scope. I can't say like it will be zero, but yes, it will be very minimal. Okay, we have like other strategies how to minimize this. We have guardrails and all those things, but just for now, let's stick to what we have at our hands here. So we have now solved all the limitations that are available with the traditional AI, right? So with the LLM, initially we were unable to answer any real-time questions, but with the introduction of vector databases, we are able to answer near real-time questions, not exactly real-time, but near real-time. If something I updated in the morning, yes, then I can pull it. But every time I can't just refresh it every second or so on, right? So you have to trigger this whole pipeline every time. So that is the reason I'm saying like near real time. So if you have trigger the pipeline once in a day, in the morning or sometime, yes, your data will be like fresh till date. So that is how you fetch near real time answer. You can get near real time answers from the LLM. And the other thing is your answers are grounded, right? So you don't get any hallucinated or incorrect responses. Okay. So now I hope everyone understood the architecture of RAG, how it works, and how it helps. Okay. Now, let me just quickly iterate a few of the things just to, what we have discussed. I'll just go through them. And before going further, let me also tell you a quick thing related to the context window. So yesterday we already went through it, but I just wanted to reiterate this before we go further today. Why? Because this is one of the crucial thing. So what is a token? So you might be thinking like, I mean, going further, I'll be using this word more further. So I want to make sure you all understand what is a token and all that stuff. So basically, token is nothing but it is a basic unit of data that the model uses to process and generate text, right? So just to make you understand, see, please try to understand the reason I am trying to repeat this important concepts is these are like fundamentals, okay? Like any framework like LangChain, LangGraph, if you ask me like all the other recent things, right? You will get each new framework every month, but the fundamentals, right? Those doesn't change. So I really want you to understand these fundamentals very well. So that is the reason I'm just repeating this stuff. Okay. So a token is nothing but the basic unit of data. That means it is not a word, it is not a sentence or something. So how do we divide that? Yesterday we went through few of the examples, right? So as we spoke, like we have a long vocabulary, right? During the training of the LLM model, we downloaded like long or humongous data from the internet. And what we have at hand is if we take unique words, like for example, playing. Okay, let me just say play, playing, played, plays, player. I mean, there might be a number of words with it. But if you see these things, right? So I have to store this word play as individually. Play, I have to, if I give individual tokens to unique token ID to each of this. So like something I might be giving 1 2 3 for this, and 1 2 5 for this, 1 2 7 for this, 1 2 8 for this, and 130 for this. I have to store all these token IDs in my vocabulary section, right? So if I had to store each unique word, how difficult it would be. And tomorrow, like let's say we have millions of such words, right? Like we might be using jargons like anything, instead of played, we might be sometimes simply using something like this, or we might, I mean, the shortcut or whatever it is, right? So, like, let's say whenever we have this I would, we will just say I and D. Instead of would, we will just say I comma D, right? So we use like a lot of jargons. We have to give unique token IDs to each of this, right? So coming back, in order to store all these things and process all these unique tokens, it will be like pretty much we need a large vocabulary, which requires large memory and large number of computations are required. So how we minimize this? As we just discussed about the context window, we have to have minimal context window. We should have a minimal input to the LLM, right? Such that we will incur low cost. If we keep on increasing our context window, right? So what happens in general? If we keep on increasing the context window, our cost will be increasing. So how do we minimize the cost? If you minimize the computations that happens in the background, you are automatically minimizing the cost associated with it, right? So here what we'll be doing is why to represent each of them in a unique way, or why can't we just write play, okay? And we are just teaching the model these words, okay? Instead of teaching the repeated words every time, I will be just teaching them, you just remember these words in your vocabulary, okay? Which is play, ing, ed, yes, and er. So whenever I am, assume I'm giving these tokens here, and whenever I want to indicate the words that I see, what I'll be doing is I'll be saying like, okay, it is a combination of 1, 2, 3. It is just a 1, 2, 3. Then I'll say it is a combination of 1, 2, 3, comma 1 to 5, right? And then I'll be saying that it is a combination of 1 to 3, comma 1 to 7, right? So if you see here, I have like very minimal vocabulary, right? Like next day, I might be saying that eating, eat, eats. Okay. So here, if you see, eating might have something like 145, but eating, right? What I can use 145, comma 125, right? So here I'm not storing this eating word completely again. I'm just using this eat here, and the ing from the previous I mean, previously what I stored when I'm training using the playing, right? So I'll just use the same 125 here. And when I say eats, I'll just use 145, comma 128 here. So that means here my vocabulary size is minimal, right? So this is how we bring down the overall token count. So if we have a better tokenizer, then our overall tokens will be less. And if you compare it from last 3 years, so it has improved around 30% in general, to be honest. So this is how we compressed our vocabulary. Okay, I hope everyone understood why we need to convert tokens in a specific way and why those are not in order. Okay. And there are like multiple tokenizers in general. I will not go through them in detail right now, but for simplicity, as you most of the GPT models use byte pair encoding, which is BPE. That means it will just take repetitive words. Like let's say initially, if you give this vocabulary to the model, or initially it will say E, it will say A, and it will say T. Then we gave another word which is eating. Then what it will do is, oh, EA is very repetitive. So instead of E, it will just take EA as one token. Okay, and T as other token. And when it comes to third word, and it will say, oh, it's this EAT is like constantly repeating, and as if it repeats frequently or more number of times, it will consider this as a common word in most of the characters, and it will consider this as a unique whole one word. Okay, I hope everyone understood till here. So it basically does whatever is frequently appearing, it will just try to append it and consider it as a token. So that is nothing but a byte pair encoding. Okay. So if after eating, you see these three words are like not matching, right? So it will just consider eat as one token, and it will say ing I as an if it is seeing eating, playing, running, and all those things, it will consider ing another thing. So I'm just giving you an idea of how it works. No, it's not exactly that it will give eat or eating, but based on the data it has, it will evolve. Okay. So now I hope everyone understood how the tokens work and how the tokenizers work and all these things, right? And how we give it to the text, or I mean in the context. So eventually what happens when once we have this token IDs, we will convert it into respective vectors. So how does vectors look like and all those things we will go through in detail. Okay, I'll show it here. Now let's come and just reiterate the same thing. RAG is nothing but retrieval plus generation. Okay. So where we had to retrieve relevant information, and we had to generate like answer based on that information. Okay. So user asks a question, maybe it is about the team's budget or something, and we will fetch that information based on all the finance documents that we have in our knowledge base or vector database, and then give it to the LLM in as part of the context, and the LLM will generate an answer. Okay. Here is a simple flow, the same thing. Okay. So user asks a question, system searches in the knowledge base, retrieves relevant documents, sends context to AI model, generates answer. So this is a flow you need to remember. And here, if you see, without RAG, when we ask about leave policy, AI just says something like a generic answer, stating that, okay, most companies offer 15 to 20 days. But with RAG, what happens? It has access to all the company documents, right? So it will be able to give you a specific answer stating that your company provides 18 PTOs plus 5 sick days. All right. So this is how it works. And now let's come to this topic and understand how the documents are being converted and all this stuff. So we saw how we have all the documents and how we discuss like how we convert them using an embedding model into a vector. So if you see, this is a vector. Okay. So here you see this dot dot dot, right? Like whenever I say a vector of 768 dimensions. Okay. So that means it will have 768 values here. So this is 1, this is 2, this is 3, this is 4. Similarly, you'll have 768 values. Okay. And when you say 1532 or something, I mean 1532 or 1536 so on. So that means it will have 1536 values in your vector. Okay. Always remember the size should be same. Okay. You might have remembered in your schooling that whenever you want to do a dot product of a matrix multiplication, you should have the same size. Okay. So if you don't have the size or shape same, then we won't be able to perform the matrix multiplication. That is a fundamental rule. So that is why whenever you are using the embedding model, right, here, just you have to define same size here as well as same size here. You should use the same embedding model with the same parameter configuration and all. Okay. I hope everyone understood this point. Now, let's discuss about how the RAG has evolved. So we went through um, like all the things, right? Like how a basic RAG works and all that stuff. So in the pre-RAG systems, that means when RAG was not there, models like GPT-2 was just able to give the static the answers that it knows based on the training data. But in the early RAG search, we have like keyword search. So instead of having the vectors, what we do is RAG is nothing but retrieval, right? So whether we are retrieving vectors or whether we are retrieving based on keywords, it doesn't matter. Okay. Remember this, it is very crucial in interviews. Okay. So if someone asks you, do you need vector database in order to develop a RAG application? No. The answer is no to it. Vector database is one of the useful um, approach to go, but there are like other approaches also where you can perform RAG or retrieval. So we can also, just do based on the keyword search. If I'm asking something about HR documents or leave policies, And in my chunks, if I have something about the leave policies, so it will quickly pull that chunk for me, and I can generate an answer. So I don't need to convert it into vectors or so on, like a say SQL query. Okay, so I can perform a SQL query and get that also. And we have modern RAG where we have embeddings. That means the vectors or the vector search. And we use tools like Fires is one of the Facebook AI ones, similar to Facebook AI, similar to such something. The full form is. So you can use ChromaDB, Pinecone, and all those things. Okay, and then we have like all the models like GPT-4. So then comes the advanced RAG systems. So what is advanced RAG systems? So in the advanced RAG, we have like C-RAG, corrective RAG, graph RAG, and all these things. So we have like these are mostly used in multi-agent systems where, we will be using cross encoders for re-ranking and we'll be using hybrid search. So what is hybrid search? Hybrid search means it is a combination of both vector search and keyword search. So now you can ask me, okay, when we have vectors, why do we need keyword search again? So initially, let's assume why we moved from keyword search to vector search. Okay. So let's say, for example, I have the term called leave in all my documents, but the user is asking something about what is my absence um, policies. You know, being a human, we can understand this. These two are like same, right? Leave or absence policy are same. But in your documents, if you only have every time you stated it is leave policy, or leave restrictions, or so on, whenever you do the keyword search, it will not hit or it will not find a match, right? So as it is unable to understand the semantics of it, so it will not be able to retrieve the right chunk of documents. So that is when we move to vector search. So vector search will basically understand the meaning of it. Okay, for if you see, observe the vectors of leave. Okay, if it is 0.1 comma 0.2 comma 0.3 or so on, for the absence also it will have a similar vector. Okay, so whenever it does dot product, it will get highest score close to 1 and it will pull that vector for you. So that is the use of vector search. So that is the reason we brought in vector search. Okay, so initially we had like keyword search, then we brought in vector search, and then we brought in hybrid search. Now you can ask me, oh, when we have vector search, why do we need keyword search again? So we are good with vectors. These are able to, understand the context very well, meaning very well, semantics very well. So why do we need keyword search, or why do we need to couple the vector search along with the keyword search? Let's say we have some medical terminology or legal documents. Okay. So if you see the terminology, it might look more similar, but they are not similar, right? They will have a minute difference, but they can completely change the meaning of it, right? If I'm saying something like C6H12O6 or methyl alcohol or methylamine, let's say, for example, I'm not a medical expert, excuse me on that. So let's say I'm giving a word, methyl alcohol. I mean, I'm just randomly generating this word. So other one is methyl alcohol nicotinamide. Okay. So if you see here, whenever I'm performing vector search, all the vector search things is this is a keyword, right? So it is just like a name of something. It doesn't have a meaning. It is just a name. So what it does is, oh, probably these two are similar, and it will, whenever I ask about methyl alcoholamine, it will also pull me methyl alcohol nicotinamide, right? Why? Because either first two characters are same, or some understanding will be same, some properties will be same. But in general, that is not what I require, right? So what I'll be doing here is when I do perform keyword search and vector search, I'll be instructing something like for these kind of words, it will give me a score. Whenever it is 100% match, the keyword search will give me a score and the vector search also will give me a score. So based on that, if it is 100% match on keyword search, I will pull that information. Okay. So That is how it is more useful in medical or legal ways or anything. Like if you have any terminology specific or keywords that are like your domain specific keywords. If you are in an industry, oil and gas, or any industry, if you have some domain specific terminology or keywords, this will be very, very, very useful. Okay. So that is the reason we go with hybrid search. And then we have graph rag also. So I will go through that in detail if time permits. So where you will store, you might have heard something about Neo4j and all those things, right? So what is this Neo4j or graph database? Basically, you can store all your data in the nodes in a graph and identify the relationship between those nodes. So whenever you are trying to look for something, so you will make a query, graph query, and then you will retrieve that and provide it as a context to the model. Okay. So these are some of the advancements of RAG. Then let's just briefly describe the RAG architecture and we'll move forward real quick. So we might have a lot of data sources. The data sources can be PDF, databases, APIs, or anything, right? So then we have a embedding model. We need an embedding model to convert all of our chunks or textual information into numerical format, which also stores the meaning. Then we have a vector database where we want to store all the vectors. Then we have a retriever component. So this whole user query plus we perform all the calculations and then we retrieve the relevant chunks based on the similarity score. Then we will provide it as a context to the LLM and we will generate an answer, right? So there are like a lot of use cases for RAG. So, if you want to create any internal knowledge assistants like Workday assistants or, any customer support chatbots, like if you are working with any banks like American Express or Chase or any banks. So basically they are giving you a Q&A chatbot in order to answer all your queries and fix issues. Like probably Uber is also using this a lot. You might not even able to differentiate whether it's a person or a, you know, um, person or a AI application. They will have the same human name, something like, Ambika something, and it will just keep on answering your questions. And have matured a lot. You wouldn't even find a difference, to be honest. So then we have healthcare, where in healthcare also we use this RAG for clinical decision support. So whenever we want to search few quick documents or any machine related information, how to operate a machine, or are there any updates to it, or how do any recent manuals that has been utilized for the surgery equipment or so on, or if they want to make a decision or anything clinically, they are using these assistants as well. So you might be hearing that, like, once approached a doctor where they have a mic. So they'll be saying that, okay, I have observed these are the symptoms, these are so and so, and I would like to order them an MRI and so on. Can you schedule that MRI for the patient tomorrow or something? So the agent will automatically do that stuff. So it will schedule a calendar event where they have to go for an appointment and all that things. So they doesn't need to manually open a calendar, look for it, and just not do anything. It will just do it on its own and send a confirmation email as soon as it's done, a notification kind of thing. And then we can also use it in compliance and fraud detection as well. Okay, it helps most of the risk investigators in the compliance or fraud detection division to how to detect them and, troubleshoot them and mitigate them. Okay, so now we have discussed what RAG is, what is the architecture, and eventually how it has evolved. So now let's come to the crucial part, evaluation. So why we have an application. Okay, now we need to deploy it into production or to the customers, right? But can we blindly believe whatever we have built till now works efficiently? No, right? There might be some failure parts also. How to identify those pain points and how to make sure that your whole RAG application is working as you intended. So that is when you deal with evaluation part. So evals are pretty pretty much needed and a mandatory component. Okay, you cannot skip this part at all. If you are a student or a fresher in an interview, evals will give you an added edge. If you know more about the evals, the chance of you cracking the interview will be very high. Okay, so everyone will explain how a RAG works and everything, but you should be able to explain when it fails and how do you rectify it. So if you are explaining this particular component to any interviewer or so on, so that will leave a very good impression on the interviewer. Okay, so even when I interview people, my go-to questions will be like, okay, you have what you have built, and the next question will be like, okay, how did you evaluate your application? So how then he has to come through all these evals, he has to explain what he has done and all. So if the person hasn't done his homework or groundwork on all of this, we can quickly identify them, right? So this plays one of the crucial important in judging a candidate. So here basically our RAG is of two components, right? One is of retriever and one is the generator. So we will split this into two eval frameworks. So on the retriever side, we can evaluate it for context recall, context precision, and relevancy. So what is meant by context recall and what is meant by context precision, what is meant by relevancy? So you might all know in general what is recall precision, but let me tell you once again. So whenever a user asks a query, I'm retrieving some documents, right? So when I retrieve some documents, uh, let's say the user asking about leaves, okay, and I retrieve top five chunks from the vector database. So how would I know all the five retrieved chunks are in line with the user query? So I have to evaluate, like out of those five, only two might be pretty accurate to the user question, and the rest of all might be something else, right? So in general, for example, when I ask the question, the same leave policies question, I will retrieve top three. So in the top three, when we calculate these metrics, it will give you something like out of all the relevant documents in my vector database, I have, suppose, okay, let me just write it here. I have 10 chunks related to leave policy or 10 vectors. Okay, I'll just say 10 vectors related to leave policy. So during retrieval, I asked the retriever to pull top five chunks. Okay. So yes, it did pull top five chunks. Then how do I calculate recall is something like out of all the relevant documents. So how many are there? There are like 10 relevant documents, right? Out of all the relevant documents, how many I re- like how many of them I retrieved are from this relevant documents? If I retrieved five chunks, and in these five chunks, only three of them belong to leave policy, okay, and two of them state about leave policy, but not specifically. It might saying something about a different policy or some absence or rules about if you are absent for 3 months, you will be terminated or things like that. We might have a number of information, right? So it might be some other rules or guidelines. So this might be belonging to other policies. Okay. So all we are retrieving is based on the scores. So if we have like, other meaning in other policies also, we might able to retrieve them. So here if you see, you have retrieved only three of them that are belonging to the leave policy, right? But in actually have 10. So your recall will be something like 3 out of 10. Okay. So this is how you determine a recall. So when it comes to precision, precision is also something like out of everything we retried, sorry, out of everything we retrieved, how much are actually useful? Okay. So let's say you have retrieved four documents. Here you have retrieved, sorry, five documents, right? So out of these five, only three of them are useful. So your precision will be something like out of five, only three of them are useful. So this will be your precision. Okay. And relevancy is something like how many are relevant to the user query and so on. Uh, Things like that. Okay. And when it comes to evaluation, now let's move on to the generator metrics. So in evaluation, we have like faithfulness, answer relevancy. So faithfulness is nothing but there is other one called as correctness also. Okay. So what is correctness? So whenever a user asks a question, were we able to provide the correct answer or not? Okay. That is one thing. And the other thing is faithfulness means how should we believe the model? Like whether it is generating any hallucinated answer or it is generating a grounded answer. So that is another thing. And relevance is like how relevant is the answer provided based on the context that we have provided. If you see here, retriever metrics are only evaluating till the part like what is a user query and what we are retrieving here, like just till this part. Okay. So your input is user query and you retrieved some data and you are comparing these two and evaluating it eventually, right? And when it comes to generator, this will be your input. The context is your input and the response that you have here, this is the output. So you will compare these two and state these metrics whether the response that we got is based on the context that we provided or not, and the response that we got is able to answer the user query that is in the context or not. So this is how you evaluate both the retriever component and the generator component. Okay. So I hope everyone understood this part. Now let's come to other important thing, which is LLM as a judge. So why do we need it? So for example, when we are evaluating these things, right, like when we are doing all the faithfulness, correctness, and answer relevancy, what you have to do is you have to have a manual person and you have to tag them. Like initially, you need to say, okay, this particular answer generated by model is correct and this is incorrect and so on, right? So you will evaluate manually. But what if you have thousands of records or millions of records? So going through them manually and evaluating them will be very difficult, right? So that's when we introduced LLM as a judge. So instead of you manually evaluating all these metrics, the LLM will do the job for you. Okay, so it will do the reasoning, proper reasoning, and it will look for evidence usage and also it will look for logical consistency as well. Okay, and it will give you all the respective scores, like whether it is passing all the faithfulness, correctness, and all. It will give you all the respective scores, and based on that, it will say it will give you all the metrics. So now the critical component is then you can ask me, oh, this is also an LLM, right? So don't you think do you think this will always give a correct answer? No, it will elevate or it will reduce the manual labor that we put into evaluating our application for thousands of records. But in general, this particular LLM will be slightly higher version of whatever we are using in the generator. If you are using in the generator like 5.1 or something, you might use 5.6, or you can use another version or any other different model. And yes, there is still a chance that this particular model might give a wrong answer. There is some bias. So how does it does that? So there is always a bias for any LLM. Okay, as I was discussing earlier, right? We will go through bias in more detail, but I'll just give you a few examples of how when a bias happens. So let's say if you are giving like lengthier context. Okay, so if your out generator generates a larger output, like maybe the output is something like 2000 tokens. So this LLM always has a tendency or bias towards lengthier outputs. If you have give a lengthier output, this LLM thinks that is a correct answer. So there is some bias involved. So people are still working on how to improve them a lot, and like there are like a lot of components. So, but in general, if you have a structured output, this will be like very much useful. Okay. So I hope everyone understood how do we evaluate all the evaluation and all. And let's discuss few of the challenges in RAG. So whenever we are retrieving something, if our retrieval quality is poor, okay, so maybe we have used lower dimensions like 512, and we might be chunking a huge paragraph or something which has a lot of information, and we are only creating vectors on 512 dimension, then what might happen is we might not have stored the meaning properly in the vector, not enough meaning in the vector, and we might tend to get a poor retrieval, I mean, different vectors than the one that we intended to retrieve. So when we are not retrieving correct vectors, that results in poor retrieval quality. And as I told, hallucination is still possible. It is minimized, but not completely eliminated. And latency issues. So because of all these components, right? Like when you are retrieving, if you use a cross encoder in between. So I will talk about cross encoder in a minute. So there will be some latency issues. If you use CRAG, corrective RAG, there will be some latency issues. So we have to fix all those things. And chunking strategy complexity, as we have discussed, right? So earlier, uh, so now let me come back to this CRAG like real quick. Okay. CRAG or cross encoder. So what happens is in the cross encoder, like let's say I want to fetch all the recent investments of a company in a particular semiconductor field. Okay. So I'm saying it to retrieve top 50 chunks such that I don't want to miss any investment in this particular field. Maybe my company might have invested like in 100 different fields. I mean, like maybe it has made 1,000 investments, assume. And out of those 1,000, maybe 40 or 30 of them might belongs to semiconductor field. Okay. So if I only do top 10 or top 30, there might be a chance that other investments which are like slightly related to semiconductor field might also flow in. So I don't want to slip through any of the investments that belongs to the semiconductor field. I'm just taking a larger quantity of it, which is top 50. But my actual investments are only top 20, only 20 or 30. So what I'll do is initially I will retrieve all these top 50 chunks. But if I provide these top 50 chunks to the model, what happens? My context will be big. That is one thing. And the other thing is I might poison my context. So there are like 3 to 4 terms, which is called context poisoning, um, and context, I mean, confusion, and like one more term I forgot, but I will explain you those things eventually. That's just on top of my mind, but I'm unable to recall it. So there are like few things. So what happens is, so whenever you provide larger or unnecessary or noisy information in your context, the LLM might confuse, right? And it might give you a different answer. So that is why what you will do is you will use a re-ranker where this particular for the re-ranker you will be using cross encoder models. Okay, so these cross encoder models will help you re-rank the chunks. Let's say you have retrieved 50 chunks, and based on the user query, it will re-rank them accordingly, like from sort them basically, like 1, 2, 3, 4, 5, and so on. So then you can filter the most relevant chunks from that 50. So once you sort it, so it will give a score once again, and based on that, you can now retrieve top 20 or top 30, and you can provide it to the LLM such that your context window will be reduced and you are more aligned with the user query. Okay, this re-ranker will go through your query and will go through your retrieved chunks, and then will only extract that are like actually relevant. Okay, so you doesn't provide any noisy information in the context such that the model might either confuse or it might be like go in a negative direction. So that is the use of this re-ranker. I hope everyone understood this point here. And as I was telling earlier, right? So this is how any RAG works or a hybrid RAG works. So something like whenever we have a keyword like INC44521, this doesn't have any meaning to it, right? So during those things, you can like quickly do a vector search and retrieve that, so that you will always retrieve the same information that is related to this particular document ID or case ID or something. Then we have graph rag. So as I told, we'll be having, whenever we have some customers, we have some relationships defined and the entities that are associated to, and then we'll build a graph, and then we'll simply retrieve using graph query language and provide it as a context to the LLM. Or you can use AI over there as well. And then comes the agentic RAG. So this is like used in the recent days. Okay. So it will decide whether the retrieval should be of one step or it should be of multiple step, how it decides. So initially, whenever you give a question, the planner agent or the orchestrator agent, they will decide what to retrieve and where to retrieve and when to retrieve. Whether it is at step one, step two, step three, or step four, like it will decide all these things and do the retrieval as needed. It will not just directly go and fetch the retrieval first and keeps on appending to the context. No, it doesn't do that. Initially, it will try to identify the steps, plan it accordingly, and then it will decide what to retrieve and where to retrieve and when to retrieve. And once you retrieved it, it will analyze and it will think, oh, okay, whether the overall data is retrieved or do I need to do more retrievals and all those things. Okay, that is agentic RAG. And there is other thing which is called as corrective RAG. So corrective RAG is nothing but whenever we retrieve a documents, right? We will pass it through a LLM agent or cross encoder, and then we will identify whether if the retrieval quality is poor, whether it has to do a retry or whether it has to reformulate the query. Like sometimes, the user might be having some mistakes or some grammatical mistakes or something else, or maybe providing vague information. So we'll try to reformulate the query by some of the information from his past history or memory or something from the profile. And then we will fetch the relevant documents. And let's say we still got the retrieval quality as poor. Then what we'll be doing is it will try to go and look for website. I mean, it will search the web and it will try to fetch information if anything is available, or it will just say, you have to go for manual retriever or documentation is not available or use another alternative retriever. So when you have multiple retriever components, this thing will be like more useful. And the other thing is hierarchical RAG. So here retrieval occurs in layers. Okay. So in first layer, it will retrieve relevant documents. So you'll only have information about the document, but not specific chunks inside that. And then in the second layer, you will have retrieve more relevant chunks inside the document. It is something called as like a vectorless RAG or so on that is you are hearing. All these are vectorless RAG, to be honest. Okay, this is also like not this. This graph RAG is also vectorless RAG, and like other keyword based RAG is also vectorless RAG, and all those things. Okay. So I hope everyone understood the concept of RAG and how we uh, build an application and how we evaluate it and how we put into production. So I will pause here. Okay. If there are any questions, please feel free to raise your hand. And now I'll open the dais for questions. Okay. Uh, okay. I see a few hands. Just give me a minute. Mm, okay. Okay, Senthil, yeah, can you unmute
Uh,
yourself?
yes, hi Shripal. Thanks
Yeah.
very much for this useful session. You are taking really easy, nice. My question is on the corrective RAG. In
Mm-hmm.
terms of GitHub Copilot, I have seen, for example, a given task, it splits into to do, and then it does something, and then it says, "Oh, I made a mistake," and then it goes to correct. Is this similar to the corrective RAG?
So actually, GitHub, I mean, okay, try to understand in this way. So GitHub Copilot uses multiple tool calling functions and MCPs and all those things, right? So it doesn't have a vector database over there, or it is not retrieving information from any knowledge base. All it is doing is a tool calling function and fetching some information.
Okay. So if they are different, okay, my question still is in the corrective RAG, we say that if the retrieval quality is poor, so
Hmm.
how does the system know or the LLM
Hmm.
know that the quality is poor?
Yeah. So what it will do is you have the user query, right? So
Uh,
it will take the user query and it will take the retrieved chunks and it will analyze whether the chunks are able to answer the user query or not. So there will be another
Okay.
LLM in between. Before sending it to the actual generator, there will be like other SLM, like small language model or something, and it will evaluate whether the chunks that we are retrieved is able to answer it or not. We don't use a larger language model, but it will be a SLM which will like quickly validate whether those are like if it feels relevant or not. So, like for example, I'm asking about leave policies or something specific to my leave policy or something specific about medical leave policies only. Okay. So in that
Mhm.
case, what happens is if the model retrieves about all the PTOs and sick leaves and all the other things, but not something about, we have some leave policies specific to bereaved leaves or maternity leaves or paternal leaves, right? So
Mhm.
the model might have retrieved chunks that might be related to PTOs and sick leaves, but not about these bereaved leaves or paternity or medical leaves. That means it didn't retrieve the right information, right?
Okay.
So that is when it decides, no, it didn't retrieve the right information. So again, it will do a requery or try to get it from other tool calling or so on.
Okay. So in that case, the SLM has to redo the same task like the LLM which did retrieve the relevant chunks, you mean?
Yes. So again, what it does is, like there are multiple ways. I just give a basic example of what it is. So in general,
Mhm.
when character rag happens is, you might have seen that you will give a small instruction to a chatbot or something, then the orchestrator agent or the planner agent, right, it will rewrite your queries accordingly. Oh, the user is asking something about this, so let me rewrite my query, and it will again try to fetch it from the vector database. So when it rewrites the query, right, so you might get different vectors. So when you
Okay.
rewrite the query in text, your vector representation will be changed slightly, right? So that
Okay.
vector representation, when you do similarity search, you will get different set of vectors. So then we will evaluate, oh, whether that was able to answer your question or not, and all that things, and we'll give an output based on that.
Okay. Got it. Thank you very much.
Mhm. Yep, sounds good. I see a question from Surya. Can you describe top P? Okay, top P is something on the LLM side. Those are like LLM configuration parameters. P means probability. So yesterday we discussed something about next token prediction, right? So, um, okay, do I have any text here? Or else I'll just write, let me just write this sentence. Mm, the cat uh, has four legs. Okay. So what does the LLM basically does is when I say four, all it does is to predict the next token, right? So it might be stating that the options are something like, okay, legs, hands, tails, eyes, or so on. Okay. I mean, let's just take the, uh, yeah, nails, not tails. Okay. So now we have like these three words. Okay. And these three words will have a probability, something like 0.8, 0.2, or 0.15, and 0.05. Something like that. Okay. You will have the probability, which is close, which will, when you sum them up, it will be equal to one. Okay. So whenever you give, I mean, you have these four tokens and you want to predict the next token, what does the LLM decides is based on the top probability. If you say top P, you are stating that, like if I give top P as like 1 or let's say 0.9, okay? So it will only consider the options that are available in 0.9. Like if I sum this up, 0.8 plus 0.15, right? It is exceeding the 0.9 boundary. So it will become 0.95. So it will only consider this particular legs and give an output here as legs. Make sense? So if I define something like which is like greater than 0.65 or something, so assume I have this word as 6, 0.6, and 0.3, and 0.1. Okay. And if I'm determining my probability should be greater than 0.5, right? So, like, whenever you define this top P, right, all it does is it will do the cumulative sum and give these options to the model, and you have the creativity. So, based on that creativity, either it will pick the first one or the second one. Make sense? Okay. Uh, okay, I see other question from Ashutosh as well. Like, let me answer that. So, how do you do faster retrieval from vector index or vector DB? How to do faster load of similar records in vector DB? Okay, so the vector search or vector DB, right? The matrix multiplication itself is very fast, but still there are like certain indexes. Okay, inverted index is one thing that we have where we can index all these vectors, and we have HNSW, hierarchical navigable small world. So that is another faster approach on how do we narrow down to our respective vectors. So those all helps us in loading or fetching the vectors very fast. Like hardly it will take 0.2 seconds in GCP if you are doing it, to be honest. Um, okay, we have me. Yes, Ashutosh. Yeah, can you unmute yourself, Ashutosh? Yes. Hello. Okay. Balakrishna.
Yeah, please try to unmute yourself and try to talk if you raise your hand. If you raise your hand by mistake, please try to.
Hi Shripal, good morning.
Hey, good morning.
Yeah, I have a question regarding how to create new RAG. So you're using any language or you can prompt to giving.
So you want to build a RAG application, right?
Yes, yes. And
So when you
second one is that how to developing a new prompts for the RAG.
okay, see, the prompt part will always comes on the LLM side, okay? So in the RAG, your retriever and generator. So whatever way you want to, fetch the answer or how you want the output to be, you can instruct all those things in the prompt. The retriever part, all it does is whatever you are giving as a user query, okay? It will just try to fetch if there is any relevant information or not. If not, like if you think your user query will be something different, but you want to only extract based on few terms that are available in the user query, then you will slightly need to break it down into multiple components. Something like initially you will get a query, then you will extract the entities from that query and try to fetch the information based on that query. For example, let me tell you, in the customer support chatbot, you are working for a retail organization. So what you'll be doing is a user comes in and he wants a refund. He will say, "Oh, I need a refund for my recent product that I bought in." So then, if you do a vector database search, you might not have enough information. Initially, what you'll be doing is you have to fetch the documents that are ordered by the user, right? So you will go to his order history, you will fetch those documents, and then you will rewrite a query stating that to what category the order belongs to. Like, let's say he ordered some, vitamin C or some serums or something else. So then you have to fetch information from your knowledge base to provide that instructions on return or refund, right? So here, when you are doing the retriever component where you are trying to pull the information from your vector database, then you will rewrite your query to fetch, what are the instructions on returning this particular category product or how do I, like, what are the refund policies of this particular category. Then you will perform similarity search on the vector database and you will fetch it. So a vector database is like a physical component. Like how, I mean, it needs memory, how you store all the traditional databases, right? So you need a server and you need to store it over there. So here, uh, the way you rewrite this query, the way you break this into components is how you need to deal with. And once you retrieve it, and you will append this in the context and give it to the LLM. So that is where your user query comes in. So if you remember in the earlier context engineering window I gave you, right? So the RAG or retrieved information that you see here is purely based on whatever you are retrieving from the vector database. So if user has a query, something about leaves or refund, like let's say, you will just pull it from your troubleshooting guide on how to issue refunds. Okay. Then it will fetch some refund related chunks for you. And here is the user prompt that you need to update accordingly before sending it to the LLM. So if you want your LLM to behave in a specific way or output the answer in a specific way or reason in a specific way, you will provide all those instructions in the user prompt. That is pretty much like how you give it with retriever component or without retriever component. It will more likely remain the same. So whenever you have retriever component, you can say something more like, okay, give answer the questions based on whatever you have retrieved and do not hallucinate and all those things. So those are the changes that you'll make to the prompt in general. Make sense?
Yes, Sripal, thank you. Yeah,
Okay,
yeah.
sounds good.
Because I received query from last my interview,
Hmm.
so that's why I am unable to give the correct answer.
Oh, okay. So you can always say that, user prompt is specifically related to the generator user query is specifically related to the generator component. If you want the model LLM to perform any reasoning or on top of whatever you're providing as a retrieve on top of retrieved information, then you will include that in the prompt. If not, that wouldn't change much, to be honest. So in general, what we'll be saying is in the user prompt itself, answer based on what we have at hand and like all the instructions or reasoning, um, how it should reason and all, we'll be giving those guidelines, right? So it will be pretty much the same. Just
Thank you, Sripal.
understand the
Yes,
back end
yes,
of it.
yes, yes, yes.
Okay. Now, Suresh, can you unmute yourself?
Yeah. Hi. Thanks for the session. I mean, I'm just looking interested in the course material what you guys provided in the link.
Hmm.
So it has a different phases, right? I mean, what phase is this course going to be starting? I mean, is it starting from phase one or what level the course gonna be? And can you specify the timings and who will be the instructor?
Okay, so probably our team will reach out to you on that. So we have multiple instructors. I'll just summarize for you. So it will be started from like phase one, phase two, from basics to advanced. Okay, we will teach both coding and non-coding as well. And there will be like multiple mentors, not one single mentor. So it will be from weekday to weekend, like Wednesday to Sunday. So based on, like, usually we divide it among the mentors and on the topics also, like whoever is very good at machine learning, deep learning, or like few parts of it, so they will come and teach you those things. So it will be like a whole good package for you instead of one person teaching everything. So you will learn from multiple perspectives. You will understand, like, every one of us is working in different industries, right? And different domains. So, you can learn from all of us. So not only me, see, I might have a perspective related to the agentic AI. Someone might come and say, oh, building an agent.md file is very crucial and how it helps. They might be discussing something to you, but we will always be aligned. The basics are fundamentals are always same, but on top cherries, right? Whatever we teach, the cherries on top of it, it will be like you will learn more perspectives from different domains and industries. You will get more examples. You will be exposed to all these domains. So that's why we have like multiple uh, mentors who will be teaching you that stuff. And our team will you can reach out to our team, KK GenAI team. So They will answer you all regular questions, okay?
Yep.
Yep, thank you. And anyone else? Okay, I just dropped in my LinkedIn. If you have like any other questions related to that, you can connect me over there and I'll try to do my best to answer your queries. Okay. Okay, Mr. Z has a question. I'm not from IT background. Please explain me of what kind of job I can get. Okay. So to answer your question, Z, yesterday on the starting class, I was discussing, right? Um, Even if you're not from the IT background, LLMs has dwelled into each and every field, okay? So even if you think any of the complex, topic is complex in today's or yesterday's class, don't worry about it, but just try to, understand how this works. Why? Because it helps you upskill yourself. And the other thing is, recently everyone is using this AI. For example, I have a Scrum Master who uses AI like anything. So to be honest, earlier she used to do like a lot of work, and with the introduction of AI and all the co-pilots and everything, what she do is like she'll ask to generate a report, and she knows what to prompt, how to prompt such that the model will give me the accurate results, and what are the examples I need to provide. How does like she knows how to make the job effective by prompting itself. Okay, if needed, she will give some examples or she will attach some documents. So attaching and all these things comes under like RAG only, no code RAG solution. Okay. So if you are giving a document to it and asking questions on top of the document, it is nothing but it is a no code RAG solution in Copilot. So she knows all these things. So she is able to finish her job very quickly. So similarly, the perspectives of how you can attach it if you want to explore any, if you want to connect to any tools, like let's say not only Copilot, but if you want to connect it to web search or finance related, if you want to develop any API. These days, with the introduction of vibe coding, you doesn't even need to know coding. All you need to know is just how to give the respective prompts and giving access to all the tools and all those things. So you can vibe code an whole application. Recently a guy who vibe coded a whole application, his company or his application was bought for more than 1 billion, like close to 10,000 crores. He vibe coded the whole application. So this is how you can build applications. Okay. My suggestion is, just take any cloud, okay, Codex or anything. If you want to take like Cloud 200, just take it. Okay. Just spend some 200 or something on it. And for a month, just like literally ask like whatever ideas you have, like if you want to build a website, if you want to build a financial website, if you want to do something else, just get that idea and ask Claude, okay, I want to build this, now give me a plan. After giving me a plan, like build an application for me, and whatever you want to do, you can just do that. Okay, initially try to do with the $20 subscription, and then go with the $200 subscription. If you don't have any idea, okay, like just ask Claude or ChatGPT, give me some ideas. Okay. So that is how effective it is. Just start building. It will be like more useful, whenever you want to pursue any career. So you say these things. So it will be like, whenever you project these things to your interviewer or any group of companies, right, they'll be like more interested in you. Why? Because you have like literally built an MVP for them or on your own, right? You have done a POC or MVP on your own, and they will be like, oh, this lady knows how to, I mean, not only lady or person. So this person knows how to build application and ship it, right? So just try to do it. So just get hands on first, and believe me, it will become very, very beneficial for you. Okay. So I provided my LinkedIn in the chat. So I hope everyone can see that. Okay, I see one more hand raised. Uh, Someshwar. Yeah, Someshwar Rao garu. Yeah, can you
Uh,
unmute yourself?
sorry, this is Senthil. The LinkedIn URL is not in the chat. I'm sorry.
Oh, okay. Oh, Oh, sorry, my bad. Yeah, hopefully you should see it now.
Got it. Thank you.
Hi, Sripal.
Hey, hi, Sunashwar.
Hi, good to listen your class. You are going excellently.
Thank
My
you.
question is like that. You explained the LLM as a judge, right?
Mm-hmm.
So the higher model will give you the more correct answer. Means why we are using the lower level of model, because to only reduce the cost cutting, or that means I'm asking if a in normal context we can tell judge need a more level of expertise
Oh, no,
to
nothing
tell
like that. See,
like to
here you have to identify the difference. That is, your LLM as a judge should be good at judging, not to generate
okay,
context, not to reason, nothing. Right? It should be able to judge it based on the user query and based on the context that you have provided, whether the output is in line with the input that you have provided or not. The job is just to validate it, right? But when it comes to the actual LLM model, when I say higher end model or fine-tuned model means the quality to judge. Okay, so it doesn't mean that you always need to go with 5.1 and you always need to go with 5.6. It's not like that. You can also go with like slower model, like lower version of the models, but which has higher capability of judging. Okay,
okay, like
and
so if the higher model has that capability means why we use it, why we use why we can't directly use that as an to answer the question.
yeah, that's where I'm saying, right? Like, okay, let me come back to this chat. See, let's say I have an LLM model and I have a judge model. Okay. So now I have a question, something like this particular LLM should answer a query. Whenever I ask about a refund, whenever I ask about a refund policy, this particular LLM should fetch from the retrieval vector database and give an answer, right? So
Yes.
it is not pretty, sometimes it might not be pretty straightforward, right? The user might be simply saying that I want refund, right?
Hmm.
So when you have this, I want refund for my order, does the LLM have any context to it? No, right? Even if I want to go and fetch something from my retriever, like let's say I have my vector database here. Okay. If I convert this user query into vector, it will give me a vector, right? Something like 0.1, 0.2, comma 0.3, so on. It will give me a vector. And I will take this vector to the vector database and I will perform similarity search. So I might find n number of chunks that are related to refund. But did I specify any particular order category? See, refund is not same for everything, right? Few products you don't get a refund, right?
Yes.
So for mattresses, for dresses and all, you might get a refund, but something like medical products or food produce, right? In USA or anywhere, if you order a food or something, you can't return it, right? Unless and until damaged, you can't return it, but they will refund you sometimes. Sometimes they'll say no refund, only replacement. You might be seeing it on Amazon or Flipkart or anywhere. It will say only replacement, but no refund based on user or based on seller and everything, right? So here, the LLM, if you just give this query to the retriever database, this vector goes and performs a similarity search, and it doesn't have any idea whether it is from which seller, which category it belongs to, and anything, right? So what do you do now? So you need to have an LLM, okay, initial LLM that needs to reason the user query. It will break down this user query into two. Okay, and then it will rewrite the query and it will plan what are the steps it needs to take. Initially, it needs to, fetch profile information of this user and order history. And then order history, it has to determine the category. And after determining the category, then it has to rewrite the query such that it will be converted into a vector format and then perform a similarity search and fetch that vectors. So if you see here, the logical reasoning, right? If the logical reasoning
Yes.
is complex for your application, you need a very good LLM. Okay, but
Okay.
when it comes to the judge model doesn't need all this complex logical reasoning. All you need to do is whatever output is given by this LLM and whatever input you provided to that LLM needs to be evaluated. So we will
Okay.
there are like some fine-tuned models that are acting that will be acting as a judge. Okay, so
Okay.
that is when you take these fine-tuned or specialist LLM models, okay, to evaluate the previous model. Make sense?
Yeah.
So based on the complexity, only you will decide your LLM. Sometimes, if your application is very simple, then you doesn't need complex LLM. You might go with a 7 billion parameter only. Why to go with 1 trillion parameter or 3 trillion parameter, right? See, latest models all cost more, like Cloud 4. GPT 5.6 or Opus 4.8. All these are high in cost, right? So you doesn't need those latest models every time. And based on the tokens you burn, it will be different. So if there is a possibility that you can go with lower models for your application, yes, you can go that. And you can go slightly higher for the judge model. Yes, you can go that. Or else, if your application is taking a larger model or it requires a lot of reasoning and you want to go with the latest model, then you can pick another model for sure. But just don't go with the same model. Why? Because in training, based on the training data, they might have a same bias.
Oh,
So
yeah.
that is why I'm asking you to go with a different model, which is either specialist in evaluating or go with a higher model. That's it. That is my option to go.
Okay. Thank you.
Yeah, sounds good. Yeah. Any other questions? I see Ramya Rajendran. Can you unmute yourself?
Yeah, sure. Hi. It was nice. The class was really good. I just
Thank
have a
you.
question.
Mm-hmm.
I wanted to create an AI agent. Uh,
Mm-hmm.
say, for example, like in the website, like similar to a chatbot, or if for a restaurant, like automatic telling
Mm-hmm.
something like that. So,
Mm-hmm.
where do I start from? I mean, like how to do?
Okay. So initially try to get to the use case. So based on what you have said, I will make certain assumptions. You can correct me if I'm wrong. Okay.
Sure.
So let's say you want to build a chatbot
Yeah.
for a restaurant. Okay.
Mm-hmm. Mm-hmm.
So now get to the functional and non-functional requirements first. Okay. So this will
Okay.
be like an agreement between you and the client. Whenever, in any company, if some team comes and says, oh, you need to develop this, there needs to be an agreement between you and the team, like stakeholders and your team, right? So there'll be like functional and non-functional agreements. So as this is for personal, I'm not worrying much on the non-functional. Non-functional means all the latency and all those issues. So let's focus on functional. So what it should do. So do you want the model to, whoever approaches this chatbot means it is chatting. Okay. Whether you want to attach any speech to it, then you need the speech to text or text to speech functionality to it. Okay.
Okay.
Or TTS. TTS means text to speech. Next thing is, uh, like you have the text, you have the questions, and what answers should it generate? Like, it needs to give only what are the available items that are in the menu, like what is today's menu, so what is available, or things like that, or anything, timings, whether the store is open, how much time the restaurant is open, or whether a food is like, non-veg or vegetarian, or some things like so.
Okay.
What type of answers you want to answer? Like, for example, I will simply say menu related queries,
Okay.
something like, is this order available or not? Okay. Or like, what is the price of that order or so on. And the other thing is your restaurant timings. Okay.
Mm-hmm.
And maybe prices of, I mean, in the menu itself, it will be including of prices, okay? Pricing information. And something like, you have any discounts for corporate bookings and so on. Assume
Okay.
you have that those might be some queries. And, any frequently asked questions. Okay. And other than that, like if you want to track orders, that is another tracking orders, they want to place an order for pickup or so on, like pickup orders or tracking orders, okay, orders tracking. So they will be saying that, they want to call or chat stating that, okay, I would like to order some chicken, like something, biryani or something, and they will be, dropping by and paying the amount and take the pickup. Okay, so
Okay.
these are the functionalities that I want to build. So now, if you see here, you can use an LLM for sure to give the naturalized answers.
Mm-hmm.
So you have a lot of models where you can convert speech to text and text to speech. One thing. Next thing is you have to answer queries related to your menu. So every day, like when you have a fixed menu, that's pretty simple. So you will load that by menu document to the knowledge base, like how we do with the RAG, right? So we will
Mm-hmm.
load this data into the knowledge base. And then you will give all the menu related information, how they are, if there is any product that you name it very differently than others, like something like very cool name that you give and people are not sure what are the ingredients are, you can specify all that information in your document and provide it to the LLM as a vector database. Then restaurant timings and those also you can store, and discounts and other frequently asked questions also you can store it accordingly. Like when it says discount, corporate discounts for 10 people offer 10% discount, greater than 20 offer 20% discount, so on. And if someone wants to pick up and order tracking, so this is where you have to write information somewhere, right, to a live database or structured database, right?
Okay.
And you have to follow up on that. So what is the status on it? Is it in prepping or is it prepared or on all those things? And you have to notify the customer. So this part will become, you know, earlier all this thing is like pretty much static. You are fetching information and providing an answer, but this will make your application dynamic.
Mm-hmm.
Okay. So if you include this component, it will be like slightly difficult, but it is doable. It's not something impossible. It is like easy with all the vibe coding. So initially you'll write all these functionalities and then you will start building. Okay, for this, I need a whisper model or so and so text to speech model. And then for this, I need to start building RAG application. So I need to fetch my documents and prepare a knowledge base. You have to parse all those documents, chunk them, convert them into vectors and so on. Right? If the document is minimal, then okay, you can just feed it directly. So
Okay.
then, I mean, for it is only for your restaurants, it will be like minimal. Unless you have like thousands of pages, it's a different case. So if it is for a smaller restaurant, yes, you can keep it as minimal and just feed it every time at once. The cost will be slightly high, but if you deploy any local model, right, like lower parameter model, then it should be good for you. Or else you can directly use OpenAI API, okay, where
Okay.
you can pay on based on tokens. So then, like for this pickup and order tracking, right? So this is where you need to employ some tool calling functions. So that particular tool will write your data to a user database and then fetch the data from the user database and also notify the, through messages or all those things. That will become a slightly elongated version of it. But
Okay.
this is how you approach on building a chatbot for a restaurant.
Okay. Yeah, got it. Thank you. So do we have any like no code tool, something which I can use to build this? Because I'm just doing for a POC.
Okay, so initially, what I will advise is to do is there are in OpenAI also there are playgrounds.
Okay.
Okay, like you can use Google Anti-Gravity or like simply do you can do vibe coding. Literally, you can do vibe code if you have ChatGPT access
Okay.
and you have Codex. Just give this statements to Codex and it will generate the whole thing for you. Initially, try to get a plan.
Okay.
Ask the
Got it.
ChatGPT, I want to build something like this and fetch me all the relevant plans where, I can build a chatbot that can serve a particular restaurant or so on. It will give you a detailed plan for it and take that plan and again give it to the codex itself. Now help me build a chatbot with the current plan, and then you can do the whole with vibe coding.
Okay.
For
Got it.
POC, that should be okay. But when it comes to production, right, then you need to know all the basics that we have discussed.
Okay. Got it. Got it. Okay.
How to
Yeah.
minimize the tokens, how to make it cost effective, and how to evaluate all those things. So that things come into picture.
Okay. Got it.
Yep, thank you.
Thank you.
Yes, Ravi Mukkapati.
Yeah, hi, Shripal. Thank you for the class. Maybe this is answered, probably. So my question is, I'm trying to understand. Maybe this is a dumb question. So how LLM knows, if the question needs to be looked into RAG. Is it part of application design? So the application should call RAG and retrieve the data and
Mhm,
combine it and give it to LLM, or you give it to LLM and LLM makes a call. It should be going to RAG, or it should
mhm.
can itself answer the question.
Yes.
And of course, if it's a company proprietary information, it has to be forced. But let's say something generic question, but it has to be grounded to the RAG, even though it's generic and available. So just want to understand a little bit
Yeah, sure.
briefly. And next question is, I have some ML model was deployed. It
Hmm.
has used Onyx model. Though I read again and again, maybe I need some very basic, real, simple way of explanation, like from like you people, so I can understand easily.
Okay. I will go through the first question, and then actually I might ask you to ask the second question again.
Okay,
So
sure. Go ahead.
yeah. So whenever you have an application, right? So I gave you a simple RAG approach, but what happens in general is initially, like let's say you have a user, okay? User will ask a query, and that query will first reach to a orchestrator or some people will call it differently, planner or orchestrator, okay?
Orchestrator. Good.
Yeah, let's say.
So what would be the orchestrator tools example?
So this is an agent LLM itself, okay? So basically this will decide, for example, now let me give an example of you might be using any Android phones or Apple phones. So whenever you ask something to Siri, hey Siri, what is the weather outside? Or what is my bank balance? Or you can ask me something like, you can ask it something like, oh, can you fetch me can you call someone, John? So what it basically does here is, as soon as you ask Siri, the user is asking a question. So Siri itself acts like a planner or orchestrator. Now it will think, oh, what is the user asking? And then it will try to plan the next steps accordingly. So if he is asking to call John, right? So then it will say from where it will think, it will plan, okay, in order to call John, what are the applications I need to call? Or what are the modules? Modules means the applications inside your phone. So what module should I call? So then it knows it has to call the phone module, right?
Mhm.
And when you say John, it has to also look for phone book, right? Contacts module or phone book module. And then it has to determine whether there might be multiple names with John, right? Like John K, John P, John M, John Mueller, John Color, so on. So it has to fetch the right number after clarifications, and then it will call John now, right? It will place the call. So here, if you see, the planner agent will initially decide, okay, initially I need, if in order to call John, I need to fetch the information from
Understood.
uh, phone book. So this phone book module, like where you are storing your data, right? Assume that is a vector database. So this particular orchestrator will decide whether to call an API or a vector database where you have stored your information. So your phone book is specific to you, right? So in general, as I'm giving an example, the information is available on your phone. But let's say in your company, your information will be, if you have thousands of documents, you will store it in a vector database. All it says, okay, fetch that information from the vector database, and after that, make any clarifications with the user if needed, and then execute the task. So this particular planner agent will interact with you and plans the next steps accordingly. So this LLM decides whether it has to fetch from the RAG, or whether it has to fetch from the internet, or whether it has to, execute it locally. Does it make sense here?
Yeah, perfect. So yeah, this is very a good example. So in my case, I think Airflow is being used. So is it Airflow and Prefect? Those are the common orchestrator tools used in Airflow.
Okay, no, those are like slightly different. So orchestrator is something like who manages. So on the like on the data engineering side, on whatever task that you perform, Airflow also performs like an orchestrator, but is more like a deterministic orchestrator, right? If else statements. If
Yeah,
like in the Airflow, what it has is if
yeah.
task, I mean, if some event
Conditional.
happens, conditional. Everything is conditional in Airflow. But here, you are it will plan on its own. LLM has a knowledge, right? So, okay, let me give a complex example. So, book a flight ticket from SFO to Paris. If the weather is sunny and budget is $1,000, and make it less than one stop or two stops. Okay. So now if you give this, we can't use any Airflow, right? It doesn't understand the text at all in general. So we will make use of the LLM. So the LLM will basically, what it does is it will split what the user is asking into multiple entities. So what it will do, okay, the user wants to book a flight. The goal is it will initially write a goal. Okay, book a flight based on requirements. Okay. So what it does, this is the goal. So then the orchestrator will divide this task. Okay, ticket from SFO to Paris, first thing, and weather should be sunny, and budget is $1,000, right? And less than two stops. So now, in order to satisfy all these requirements, what task it should do first, or what task it should do parallelly at first. So this particular orchestrator agent or planner agent, it will plan the task accordingly. Okay. For example, okay, what I have to do first is initially the strict requirement is weather should be sunny. So you can just fetch a weather API, sorry, fetch a flight API and just give SFO and Paris, and you need to give some dates to it, right? So where do you fetch the dates? So the dates is based on the weather. If the weather is sunny, he wants to go, right? So initially, this planner agent will decide, okay, look for weather or make a weather API call, weather tool call. Then it will fetch the weather, and whenever it is sunny, it will get 4 or 5 dates. So we will store all these dates in our state. Okay, maybe like let's say August 1st, August 3rd, August 8th. Now, the second task is we got these dates. Now we can go fetch the weather API. Sorry, flight API, right? Now I will call Google Flight API. Now, when I say Google Flight API, it will fetch me all the available airlines on those dates and also give me the prices. So I will insert destination Paris and starting from departure from SFO and all those things. And I'll give this first, I will do for August 1st. And then I'll also fetch I'll do multiple calls for August 1st, August 3rd, and August 8th. So once I fetch on all these dates, then I will look for budget. Then with all the information I have at hand from the Google Flight API, what I'll do is I will look whether the budget is less than 1,000. Then if the budget is less than 1,000, I will look whether it has less than two stops. So that I will eliminate based on my requirements. And this particular orchestrator again will give back a response back to the user. Does it make sense? So here I have utilized just plain simple tool calls for the weather and Google Flight tool, right? But if you see, it is like interacting with the tools and then deciding it, right? So you're making multiple calls in a loop. So fetching this and then again reasoning, fetching this again reasoning and making tool calls and providing a proper output back to the user, right?
Okay.
So this is the use of the planner or orchestrator to plan what calls should it make and all those things based on its reasoning autonomously. Okay.
Okay.
Yeah, it is not a conditional one like we do in the Airflow or so where we strictly determine those conditions. No, it is probabilistic one, and like a human, how a human thinks, it will think through it based on all the options it has.
Okay, so this is more like agentic, but not doing actions here, giving result.
Oh yeah, I mean, after that you will be having you have this Google Flight API tool call, right? So once it decides the respective flight, it will again call this particular API and book the flight.
Yeah.
So action is also done. Make
Okay.
sense?
Yeah, but still, what this is all being done by LLM, but in productionized environment, what
Hmm.
tools are used? So you said not the Airflow. The- uh, so how this is, orchestrated? That's
Okay.
just quickly. I mean, I don't need
Yeah, yeah.
much detail.
Okay.
Something like, I was thinking, the Airflow is what big because data science team is using Airflow. I'm also
Okay.
data
See,
engineering side
you
Airflow.
are confusing the word orchestrator with the Airflow.
Okay,
Okay. Orchestrator is just a term who manages it, right?
right.
So if it is an LLM, you will call the LLM as an orchestrator. LLMs, you will call the name of that LLM, like, you will give a name, right? Like something like, oh, you are a refund agent, you are so and so agent, you are a reviewer agent, you are a pattern agent, you are a rules agent. So that means similarly, you'll give an orchestrator agent. That's it.
Okay,
So don't confuse with the tool name or Airflow or so on.
fine.
Whichever is organizing or planning, that we call it
That's
as an
right.
orchestrator. That's
Right.
it.
Okay, thank you.
Yep, sounds good. Uh, yes, Ramya Rajendran, do you have any questions?
No, I'm good.
Okay, sounds good. Uh,
Thank you.
I think, okay, let me just quickly go through any other questions I have in the chat. Does anyone have any questions?
Shripal, if it's okay, maybe 2 lines brief on Onyx, how
Oh, yeah,
it's
you
used
have
on
the second
deployment.
question, right? Yep.
Yeah.
Can you repeat the second question, please?
Okay, so we have a classification problem. It's
Mm-hmm.
deployed into production.
Mm-hmm.
I saw in deployment instructions used Onyx model.
Okay, Onyx,
So
yes.
I tried to learn myself, but not very got into. So maybe.
Okay. ONX is nothing but open network exchange thing.
Yeah.
So when we are trying to serialize a model, right? So that is when we use this ONX. So like let's say if you have developed your machine learning model in PyTorch or TensorFlow, we will use this ONX to basically, serialize. So okay, the name itself suggests something like Open Neural Network Exchange, right? Okay, do I have this access somewhere? Okay, let me just write it here. So you have a model. It is a classification model. Okay. It is built on basically maybe neural networks or anything. Okay. So you built a model, right? Based on neural networks, you built a model, you learned all the weights and everything here, right? So once it is done, we need to package it so that we can deploy it in multiple servers and expose it for online serving, right?
Yes.
Uh, so what you will be doing is you will convert this particular neural network model with all the weights into a standard format where or standard or open format. So this particular ONX, what it will does is it will just give a open standard format where you can take this model and ship it to any server or any VM and predict and do the online serving. So in order to have that open standard format, we use a Onyx, which will just simply convert your, initially if it is a tensor model, you will save it as TF something. If it's a PyTorch model, you will save it in PF. So just to serialize this, we will just use this ONX runtime so that you can just download the model and do predictions on top of it, irrespective of whatever framework we have used.
Okay, so the
It is,
actual data is not moved. So data, let's say in dev, data is there. This the metadata, the
yeah,
is this is metadata or config you are taking it to higher
exactly.
environment and trying to run on that target environment.
Yes. For example, if I have a new model, okay, and I have some data, right? This is my training data, assume. So what happens? I will provide this training data to my model and I will calculate the error and I will fit all my data into the model. That means the model will learn all the patterns from my training data, right? So once the model learns all the parameters or the patterns from the training data, it will update its own weights. So we'll do some error calculation, we'll minimize the error, and obviously, finally, we will make it to such a way that it learns all the patterns and it is predicting correctly. So once we have this model, which has learned all the patterns based on the training data during training, it will have a configurable parameters like what was the learning rate, what was the like few parameters in general. If it is a classification model in general, like a decision trees, we'll have all the hyperparameter configuration associated with it, and we want to store this, we want to version this, right? Why?
Mhm.
Because tomorrow there might be another version of the model that is coming in, and we will version all the hyperparameters that are associated with it, right? And we will give a version 1.1 or 1.12 or so on. And we will give what was the EPOS or how many training cycles that we did, how many batches we trained, like did we use any other approach? If it is a decision trees, we'll have all the child related depth and all. And we'll give learning rate, alpha and everything. Okay. So we will have all these configurations associated with this model and we will serialize it and save it. So once we save it, we will save it in the ONNX format. So if you use any other machine learning models, right, you will save it in pickle format or you will save using joblib. Okay. So all we do is we want to like serialize this model so that we can use it in different environments. While building, we might be building using PyTorch, we might be building using Pandas or some other thing. But during prediction, whatever environment you are using, this model, you can just call this model, load this model, and simply do dot predict.
Understood. Thank you so
Make
much.
sense? Yep. So basically, ONNX is a format. It's not any specific model or so on. So just to iterate on it. Uh, yes, Saxena.
Uh, Thank you, sir. Thank you for this amazing sessions. I just
Mm-hmm.
want to ask one thing that I just work on the RAG. So in
Mm-hmm.
that, when I create a environment in the VS Code, then there is an error I have getting in the like pip install LangChain community.
Mm-hmm. Yes.
So, why I getting this error in the LangChain community? If I install all the packages like Google
Mm-hmm.
or Google
Mm-hmm.
Generative AIs and ChromaDB and sentence transformers
Mm-hmm.
and unstructured tokens, structure and docs and Streamlit and all. But I
Mm-hmm.
have issue in the LangChain community and getting a error.
Okay. So what happens is, while you are vibe coding, like you're using any ChatGPT or Codex or Claude.
Yes, sir.
Okay. So what happens is, while we are vibe coding, right? there will be some statements where you are doing like from LangChain dot community import OpenAI model or like something like OpenAI model, or you might be importing something like text recursive character text splitter, or you're performing some you're importing something from LangChain dot community, but you didn't install that package or library. So LangChain specifically offers a lot of modules and a lot of classes where you can do chunking in a easy way, and where you can make use of, you can call all these models like OpenAI, Gemini and all. So now if you use OpenAI SDK, it is more specifically works only on the OpenAI side, customized to the OpenAI side. If you use Google SDKs, it is more customized for the Gemini models, right? I mean, it will still allow, but it is more customized towards their models. But LangChain will be like a common platform where you can use this framework for calling all the models. Okay. So for example, if
In
I,
the complete packages.
yes, so let's
Okay.
show you this LangChain documents. So LangChain is a framework where it helps you, in building all the agentic frameworks or RAG applications and all those things. Okay. So you have this, where is my documents? Build. Yeah. So if you see here, you can use create agent, right? Or else if you want, like, let's say you want to use OpenAI model. Okay. So you can import this langchain.agents, import create agent, and you will pass the specific model name, tools, and system prompt. And all you'll do is agent.invoke. Okay. If you want to do Google Gemini, then here, like, few models will have multiple parameters that you need to pass through, right? So then you can pick those specific ones. Like if you see here,
Which one is better?
uh, when you say which one is better, like, are you asking about LangChain is better or Google SDK is better or something like which
No,
API is
no.
better?
Yes, these like these.
Oh,
Like
these
Gemini
like
or
completely depends. If you want to use OpenAI models, like if you feel OpenAI models are cheaper and it's up to you, right? Like if you feel OpenAI model works well for me, then you can use OpenAI. If you think, Google is cheaper and I want to use Google, then you can use Google. If you think Claude is better, then you can. If you want free sources, like, you can use any Olama or all those things. So where, or Grok. So when you want to use free APIs and so on, so you can integrate all of those here. It depends specifically on the use case. If you are integrating with Azure, then this is how you do it, how you connect to you. Like if your company has all the deployments in Azure Foundry or so on. So this is where you can initialize it and invoke it. Make sense? So basically, LangChain is one such
okay.
thing. Crew AI is one such thing. There is this Agno and like Microsoft Agentic Framework, which is more suitable for Microsoft environment and all those things. Okay. Yep, there are like multiple frameworks,
Absolutely.
so just you can use anything. All of them, like the fundamentals are same. Just the class names will be different.
Yeah.
Okay, you have Llama Index also, just to.
Okay.
Mhm. Yep, sounds
Okay.
good.
Thank you. Thank you so much.
Yep, no worries.
Yeah,
Uh,
thank you. I think Sripal, we almost spent a lot of time.
okay.
Yeah. I don't see any other questions also.
Please, I posted a question in chat as follows. Okay, there is a one last question, I guess. Which
Okay.
tool, Claude, ChatGPT, Copilot, which is more effective and best result for web coding? See, it is not the tool. It is the agent harness. Like, for example, Claude has a different harness around it on how to reason whenever a user gives a question. So Claude thinks in a certain way, GPT thinks in a certain way, and the models under Claude, like Claude has different models, like n number of models, Opus models, Sonnet models, Haiku models, and all. So those models also performs differently. Under ChatGPT also we have like 5.6, 5.4 solve models and all those things. Those behave differently. So Copilot is just simply associated with all the models, like either Claude models or GPT models or Mistral or other Gemini models. So all you need to decide is initially pick one. Like, you can go with either Claude or GPT. Whereas if you are using GitHub Copilot, it is a combination of all these things. So initially, in order to build, you can go with either Claude or GPT, and they have built a harness around it. So whenever you ask a question, how to reason it, how to give effective answers to it. So initially they have pretty much built a harness around it. So you can use those and like choose models. Choosing the model will make a difference on how effective your code will be or application will be. I hope that answers your question, Parvez. Yep, that's pretty much it.
Thank you. Thank you, everyone.
Thank you
Yeah,
all.
please watch out your email for the next weekend sessions. Please ping our support number if there are any queries. So sorry for the delay for India people. Yeah, we want to make sure everybody, answered their queries. Thank you, Sripal, for, very patience and answering extra 20 minutes. Yeah, thank you. Thank you, everyone. It's a great session. Thank you.
Thank you all.